Okay, one more example right here. This time we have logarithm base 4 of x minus the logarithm base 4 of x minus 1 equals 1 half. Now this is not the kind of equation that we're going to be able to set up to use our property like we did over here on this one. But we do notice that on the left-hand side we've got two logarithms joined by subtraction, and we know that there is a rule that tells us when we have that situation, we can divide. That is, if we were to take the logarithm of the quantity u over v from our rule, it would be the same thing as the logarithm of u minus the logarithm of v. And so we're going to take advantage of that rule here and combine these two expressions on the left together to make a single logarithm. And that will go like this. It will be the logarithm base 4 of the fraction x over x minus 1. And that is equal to 1 half. Now in this case, we cannot use this property, right? Because we don't have a logarithm of x equals logarithm of y situation. But we can use our inverse property, the one that states that if we have a to the logarithm base a of x, we get x, right? So that we can use the inverse property right here of this logarithm, which is our base 4. So we exponentiate on both sides. We get 4 raised to the logarithm base 4 of this quantity, x over x minus 1. And that has to be equal to 4 raised to the 1 half power. All right, so on the left-hand side, what happens? Well, the 4 and the log base 4 undo one another and leave us with the argument x over x minus 1. On the right-hand side, we've got 4 raised to the 1 half power. Well, 4 raised to the 1 half power is our square root of 4, so that's equal to 2. So our solution is going to be one of those kind of solutions where we can multiply both sides by the LCD and solve for x. So in this case, if we multiplied on the left by the quantity x minus 1 and multiplied on the right by the quantity x minus 1, our algebra tells us that we're going to get x is equal to 2x minus 2. And now what we're going to do is we're going to solve for x right here by subtracting 2x from both sides. So if I subtract 2x over here, if I subtract 2x over here, I find that I get negative x is equal to negative 2. And so that should imply that x equals 2. Now, one last step that we should take is just to verify that this is going to work in our original equation. So we should substitute to check here as well. And I find that when I take my logarithm base 4 of 2 and subtract from it the logarithm base 4 of 2 minus 1, well, that's 1, I should get 1 half. Well, yeah, that's true, right? Because the logarithm base, this logarithm base 4 of 1, that's 0. And the logarithm base 4 of 2 is 1 half because, well, go back full circle to where we began all of our discussion on logarithms. This says, to what power must I raise the base 4 to get to? Answer, 1 half. And that's our solution. So we're done. X equals 2 is what we wanted.